Okay, this talk is called Sustainable Aquaculture Starts with Feed. And this was a talk originally given at the Aquaculture Roundtable Series, or TARS, in 2017. And so that was like a 45-minute talk. And so what I've had to do here is I've had to break it into two parts. So let me get started. So when we talk about sustainable development, the definition according to the World Commission on Environment and Development, which was later renamed the Brundtland Commission, defines sustainability as development that meets the needs of the present without compromising the needs of the future. And it consisted of three components: an economic component, a social component, and an environmental component. And then later, this was developed into the concept of the United Nations Sustainable Development Goals, published in 2019. And once again, as with other my videos, you can scan that QR code and it will take you to the page at the United Nations where you can learn more about the Sustainable Development Goals, or SDG for short. Now, with regards to aquaculture, there are really four main ones that I consider to be important for us: responsible consumption and production, life below water, clean water and sanitation, and life on land. So, if we consider the Brundtland definition of sustainability, if we consider aquaculture, we need to consider it as a global issue with local consequences, because we have an environmental component. This has to do with feed quality, feed ingredients, and effluent pollution. Then we have an economic component. So this is about employment of local labor, about family employment. It's about having a steady family income. And this is particularly important in Asia because in most locations, our farms are not large farms. There's no integrated large scale commercial enterprises. It's mostly all small scale farmers. And then we have a social component. So this is involved in community enrichment, local development, because we have local tax revenues. And you really see the benefit of shrimp farming as a means of local development and also enrichment of local revenues if you go to a place like Vijayawada in India, in Andhra Pradesh, and you see over the years just how much income has come into that community and just how much development has happened. And then we have to also consider that in Asia, most of our work in producing fish or shrimp is for export markets. Thailand, we don't consume more than 20% of our produced shrimp, and in India, it's less than 10%. And then when we start to deal with export markets, then we also have to be considering sustainability certification. When we talk about these three main elements of sustainability, it should be balanced, as we see on the left-hand side here, our ideal situation. But unfortunately, it doesn't really work out that way. The reality seems to be somewhat different. And that's partly because if we look at the developed world, the developed countries have overcome economic and social hardships. And so they focus on mainly environmental issues. So our certification schemes have come from the Western countries, from America, from Europe, and those certification schemes focus heavily on environmental issues. On the other hand, if we look at countries that are still developing, Many of these countries are focused on wealth accumulation and reducing poverty and social hardship, finding employment, and they're not focusing much on the environment. You can see here that we have most of it is focused on economics and then on social, and just a very small emphasis here on environmental. Now, if we talk about sustainable fisheries, and we need that in order to have sustainable aquaculture, I asked my favorite AI, Perplexity, to define sustainable fisheries. And it said a sustainable fishery is defined as a fishery that is managed and harvested at a rate that ensures fish populations remain healthy and do not decline over time due to fishing practices. And this whole idea about sustainable fisheries, there's quite a lot of information to back it up. We see here on this side, we have a letter to nature written by Mayers and Boris Worm from 2003. And they were basically predicting that there would be a rapid worldwide depletion of predatory fish communities. Predatory basically meaning commercially valuable marine species. And they talked about industrialized fisheries typically reduce community biomass by 80% within 15 years of exploitation. And then we have this example from the Gulf of Thailand. It lost 60% of its large finfish, sharks, and skates during the first 5 years of industrialized trawl fishing. Now, prior, we have also these other papers written by this group primarily in Vancouver, British Columbia, led by Dr. Daniel Pauly. And he talked first about fishing down marine food webs, fishing down aquatic food webs, fishing down marine food web. Okay, and it is far more pervasive than we thought. And this is the idea. So we have our large fish here at the top, and these fish feed on the bottom here. But as we catch these ones out, maybe we produce less food for these guys, which is looking at this other graphic on the other side in a moment. But as we remove these ones, what happens is these then are not really controlled anymore, and so that they flourish. If we look at trash fish, 30 to 35% of total trash fish landings in Singapore in 1974 and 1975 were found that almost 32% were juveniles of commercially important species. 47.8% were low-value species, and 22% were species unacceptable for human consumption. Now, ideally, this is what we would use for making our fish meal, but the fact is that low-valued species are low value because they're not highly in demand. But this is troubling because if these were not used in fish meal, but they were allowed to grow to full size, and trawling doesn't really allow that to happen, then what we get is, one moment, a little error here. Okay, so what we end up with is we end up with catching these before they're mature, and it does not contribute anything to the fisheries economy, which is unfortunate. So looking over here, we see this paper, History, Profiles, and Implications of Feed Fish and Fish Meal Supply from Domestic Trawlers in the East and South China Seas. So we're Gulf of Thailand, we're basically south of the South China Sea. And so When we have mortality of these guys, basically they're being caught for fish meal, then in theory it reduces the food supply of the larger fish and the population will decline. But typically what tends to happen is that we have overfishing up here, and then when we have overfishing up here, the prey animals are caught, then these little fish flourish. And so that's the consequence of that. So if we look at the status of world fishery stocks 1979 to 2019 from this graph from the State of World Fisheries and Aquaculture 2024, and you can scan it if you follow that QR code, we see that approximately now it's getting close to 25%, more than 25% are considered to be overfished, meaning that they're being fished at a rate which generally assumes that they are not being sustainably fished. And so there's a definition of what sustainable fishing is. But anyway, we see here what we have most of our fisheries are what we would call maximally sustainably fished. So this means we have scientific management, we maybe have fishing quotas, we maybe have limitations on the size of the fishing fleets. We might have, as we see in Peru, where there's an open fishing season and there's a closed fishing season to protect the ability of the egg-carrying females to spawn, in other words, to generate the next fishery. And then we have a lot of underfished. Now notice that the underfished over the last 30, 40 years has gone down and down and down. So that means we're seeing more and more exploitation. And now our low value species could be in here. Our fish that are not favored for food can be down here. But everything now, more or less, is being caught. One of the things we do need to worry about is illegal, unreported, and unregulated fisheries. This is also known as IUU. So according to estimates by the Food and Agriculture Organization, 52% of major marine fish stocks or species are fully exploited, 17% overexploited, and 6% depleted. Now this was according to the State of Fisheries and Aquaculture from 2021, a little bit older. Now, illegal fishing is one of the main contributors to the problem of depleted and overexploited fisheries. In Southeast Asia, this has continued to increase in scale from minor offenses to by local anglers to that perpetrated by large-scale illegal industrial trawlers, and this is a problem all over Southeast Asia. Violations include fishing vessels operating in other states, Thai boats fishing in Vietnam and Indonesia, Vietnamese boats fishing in Thai and Indonesia, and so on and so forth. And they don't have authorized access. They may be using illegal labor, and they may be using illegal methods or equipment. They may be harvesting protected species, and they may also be falsifying catch documents. Now, in order to combat that, fishing boats now are supposed to be equipped with GPS transponders so they can be tracked, and they are supposed to land catches. They're supposed to submit the catch documents, which, of course, as it states here, may be falsified. So if we look at capture fisheries versus aquaculture, we can basically see that of all of the uh, fish that is being caught by capture fisheries, aquaculture now is equal to it. And aquaculture production is increasing where this fisheries are not, because so much of the fish from the natural fishing are exploited maximally. Now, sometimes for us, especially for me as a nutritionist, sustainable sometimes seems like a code word for fish meal reduction. We're being encouraged to become sustainable by reducing fish meal. So, where did this idea come from? So, then we have papers like this by Naylor, Effect of Aquaculture on World Fisheries Supplies or World Fish Supplies. And when we look at all of these authors, every single one of these authors is either involved in an NGO from an environmental perspective, or maybe they're involved in different groups, but there's nobody there from the aquaculture industry. And then there was a lot of, let's say, flack about that. And later on, they then had another paper written by Naylor called Feeding Aquaculture in an Era of Finite Resources. So it's talking about the same overall topic, but here we have many nutritionists. So we have Ron Hardy, Dominic Bureau, we have uh, Ian Forster, we have Deborah Gatland, and Kathleen Hua, and these are all people who are fish nutritionists, and so then they were finally able to bring their comment in. But there's lots and lots of papers if you look for these. Now, I have not cited these, but if you look at these titles and you type them into Google Scholar or just type them into your browser, you can find them. So this one, Fishing for Feed or Fishing for Food, Increasing Global Competition for Small Pelagic Forage Fish. Okay, global overview of the use of fish meal and fish oil in industrially compounded aquafeeds. And this is by Tacon and Metian, and they've written a lot of papers. And these are the people who originally came up with the idea of the fish in, fish out ratio. And here's another paper by them. So if we look at the source materials for fish meal and fish oil, and this graphic here is based on this paper, Feeding 9 billion by 2050, putting fish back on the menu. So what can we see is that we have, of the 131 million tons of fish that's caught, approximately 18.8 uh, so if we look at the source materials for fish meal and fish oil, and this graphic here is based on this paper, Feeding 9 billion by 2050, putting fish back on the menu. You can scan it and find it there. We have a total discards of about 7 to 10 million tons. So this could be um, basically lost at sea, as it were. The fishing boats don't want to carry it, and they just dump it overboard. We have post-harvest losses, and this could be from spoilage. We have 131 million tons, which goes for direct human food use. And then we have 17 million tons, which goes for fish meal and fish oil. And about 6 million tons goes for ornamental fish or maybe for bait fish, etc. And when we look at the fish meal and fish oil, we see that we have most going for fish, a little bit still going to pig and poultry and others, but this is going down. Now, looking at this paper, Fisheries for Forage Fish 1950 to the present, remember on that previous slide we talked about as soon as you had industrial fishing that the uh, fishing exploitation level increased greatly, and we saw a big Within 5 years, they said that the fishing was 80% exploited. Well, here what we see is at this point on the graph is when Peru started industrial fishing for enchoveta, which is the basis of their fish meal. And we see that that was really the main driver for reduction fisheries, or in other words, fish meal production. And we have a little graph down here. Let's see, we can look at that a little bit bigger. What we see here is then that this is average annual catches of the largest pelagic species used at least in part for feed purposes. And we see Peruvian anchovy, Chilean jack mackerel, Japanese anchovy, chub mackerel, blue whiting, and capelin, and also menhaden. And you see um, where they're caught, and you see the quantities that are being caught. And by far the largest is the Peruvian anchovy at nearly 8.5 million tons. And this is data from 2010. So you can see that when we started the industrial fishing, that this number really, really went up, whereas these other ones are maybe not exploited to that degree because they're not fished at the scale that Peru is fishing at. So when we look at Asian fish meal, what we find is that Asian materials for fish meal and fish oil come from a mixed lot of species. And remember, I mentioned on that previous slide that nearly 30% was of the trash fish was commercially important species and the rest was not. Well, what we often find is that the fish that comes ashore from the fishing boats looks like this. And so, well, down at the bottom, this is a fish meal factory. Down at the bottom, they have some fish meal that they're recycling. But you can see that this is basically really quite spoiled already. This is well on the way to being spoiled, and maybe this one is fresher. A lot of this is actually this fish, which is called Commerson's anchovy. The problem we have with sustainable fish meals in Asia is that it's very difficult to have sustainably fished fisheries. If we look at the native range of Commerson's anchovy, we see it extends all the way from um, Java and all the way from Indonesia, all the way across to the coast of Africa. And so if we talk about quotas, what country would set up a quota for themselves when this fish is extending all across a range of many, many countries? And if other countries were not setting quotas and not managing the fisheries, any country doing it alone would feel like they're being taken advantage of. Why should we manage? Why should we set a limit on our people? Because other people then will catch all the fish. So the real difficulty that we have in coming up with so-called sustainable fisheries in Asia is that we don't have properly managed fisheries. We don't have scientific managed fisheries. Um, we don't have good data about the size of the fishery, and it extends across all of these regions. We would have to have a organization of all of these nations working together, and so far that has not happened. Now, looking at world fish meal production, and this is from the FAO, from State of Fisheries and Aquaculture 2018. Notice that I'm using 2024, 2012, 2014, 2018. I use these quite a lot. And if you scan this one, it will take you to the SOFIA 2018. But looking at here, we see that looking where fish meal is coming from, we see fish meal that's caught from whole fish is basically going down. And that we haven't seen any increase now for 20 years. It's remaining quite stable. But what we are seeing more and more is that we're seeing fish meal being made from fish byproducts. And most of the growth in supply is coming from increasing use of processing waste. So salmon that are processed for food, filleted, the heads, the skeletons, and maybe bits and pieces are going to end up being turned into fish meal. And in 2016, about 30% was from byproducts. And the IFFO estimates that by about 2030, that upwards of 30% will be coming from byproducts. So this is fish meal that's coming from food fish processing, and this is a growing percentage of our fish meal supply. Now, if we look at utilization of fish meal and fish oil from 1960 to 2020, and once again, state of the world of fisheries and aquaculture, this is 2022. You can find it with this QR code. We see that in fish meal originally, that aquaculture back in the 1960s, nothing was going for aquaculture. By 1980, about 8 to 10% was going for aquaculture. And then 2000, 2010, and 2020, by 2020, most of the fish meal was going for use in aquaculture. And use by poultry was basically finished. And there still remains a small quantity for pigs, but this is mainly for high value feed for piglets who are have very sensitive digestive systems. And when we talk about other, this may be for use in, let's say, farming animals, like fur-bearing animals like mink and so on. Now, when we look at fish oil, once again, back in 1960, aquaculture was not using any fish oil. In fact, a lot of it was being used as cooking oil, and they were also burning it as biofuel. And a little bit was going into pet food. Then when aquaculture started, well, of course, we took a lot of it. But then what happened was health supplements came along, and we started to see a lot of fish oil being used for direct human consumption. And of course, this can pay more than we can pay. And then we see that there's been some reduction going on. And this is partly due to trying to find alternatives. And the salmon farming industry uses approximately half of all of the oil. And as they realized that they were going to have a limitation, they began to use more and more vegetable oils, plant-sourced oils, which then allowed the amount of fish oil to be extended to a larger production volume. Now, I found this paper to be very interesting. Let's look at the title. It's called Towards Understanding the Impact of the Pet Food Industry on World Fish and Seafood Supplies. And this is by Sina De Silva, who at one time was the Director General of NACA here in Southeast Asia. And you can find the paper here. But they were looking at the exploitation of fish not for direct human consumption, but they were looking for where was it used. And notice, out of the total of 5.4 million tons of wild catch not for human food, 6% or 2.5 million tons as raw fish was going into raw food for cats. And then we saw that we still had some going for pigs, some for ruminants, and then also for poultry. And then the remainder going into aquaculture, going into animal protein as human food. And so the thing is that they spent a lot of effort looking at the cat food and the use of fish in cat food in Australia. And then they extrapolated that to the worldwide potential for cat food to consume fish. So this is one of the non-aquaculture uses of fish for animals. So when we talk about sustainable feeds and we talk about fish meal reduction, when we are talking about reducing fish meal, this allows greater feed production and increased aquaculture output. And so here we have this graph from the World Resources Institute, and we can see that for different species, salmon, shrimp here, catfish, tilapia, and carp, that as we learn more and more about the nutrient requirements and we learn more about how to do substitutions, then we see that not only have we been reducing, but the production is expected to keep on increasing. Now, Fry, in a paper written in 2015, showed that in the light green circle that the volume of aquaculture production was increasing. And the limited supply of fish meal would need to be reduced. So we see in 2000, 24% of the fish meal and fish oil used for aquafeeds, and then it went down to 16% estimated in 2008, 2008, and then 7% in 2020. And so we will continue to see a reduction in the amount of fish meal and fish oil in current feeds in order to allow us to increase our production volume of feeds in the future. So this was from the Sophia 2012, and we see here that we have all of these species of uh, fish that are being fed with fish meal. We see the estimated quantities of fish meal that were being used in their feeds in 1995, and that there has been substantial reduction over time, particularly in these up here, because these are primarily vegetarian fish, and there's really not much excuse for using a lot of fish meal in these feeds when these fish are quite capable of using terrestrial plants as feed ingredients. Now, if we look at the actual and predicted reduction of fish meal use relative to the global production of compound feed, we see that aquafeed use has gone down, and we see that right at the point where we began to reduce fish meal significantly, we see that the overall demand for fish meal went down because we're very successful at doing this. Now, the trend, and I mentioned it previously, is that we will see less and less fish meal from whole fish and more from fish byproducts. And the outlook is that byproducts will continue to grow. So this is some information from the International Fish Meal Fish Oil Organization, otherwise known as IFFO. And they're showing us that the mass balance for marine ingredients from 2010 data was that of 22 million tons, that 16.5 million tons were whole fish, 1 million tons was fish oil, but byproducts contributed 5.5 million tons to the total, and that then led to the production of about 5 million tons of fish meal. And on the right-hand side, we see here that based on 2012, 75% was whole fish, 25% was byproducts, and now more and more is going to be replaced with byproducts. So this is an encouraging trend, and we have certification organizations like the IFFORS, which is not a full chain certification process, but it focuses on fish meal producers and encourages them to recycle and reuse bycatch and avoid discarding fish, bring the discards and turn them into fish meal. And then they also encourage fishing byproducts to be coming from certified fisheries. Now, we do see significant differences if we compare the developed countries and developing countries. And we see that in terms of live, fresh, or chilled, particularly here in Asia, that developing countries use by far the largest amount of the fish. What this implies then is that you see that very little goes into developed countries of live, but frozen is much larger percentage in the, so let's say, the Western countries. And prepared or preserved and cured. And then for non-food purposes, a very large amount is being used in developing countries. And we look at this number, we see about 74%, 15 million metric tons is used for fish meal production, and about 2.6 million, 26% or 5 million metric tons is used for direct feeding of aquaculture, so-called trash fish, and also for animal rearing. The thing we need to understand is that we're not working to eliminate fish meal from feeds, but what we're working towards is rational utilization. Nobody in the UN, nobody in the FAO, nobody in the industry, no nutritionists are talking about stopping the worldwide use of fish meal in feeds. Aquaculture will continue to grow, but we need to use fish meal in feeds where it does the most good. Hatchery feeds for all species, and this is a high inclusion rate, but it's a small volume because in hatchery feeds and starter feeds, the quantities are very low because the biomasses that are being fed are very low. And it will also continue to be an important component in feeds for highly carnivorous species, and it can be used for feed attractability and palatability rather than as a major protein source. But there are a few species, for example, cobia, or in China, there's a freshwater, highly carnivorous species called mandarin fish. These fish are really difficult to feed with feeds that don't contain a lot of fish meal, so we'll continue to use those. But once again, the quantities are not huge. So this is the end of this first part of this talk, and I might explain that this picture I took on a trip to Montenegro a few years ago, and there's a huge inland bay that we had to drive around from the right-hand side around the bay, and we're going around to the left-hand side. And what we see here is shellfish lines to the left and fish cages in the center and to the right. So thank you very much for watching, and I look forward to showing you part 2 of this talk.